Committee of Node.js, and also Chief Software Architect at NearForm. Enjoy.
Hi, folks. Hi, everyone. How are you doing? Hey, I hope you can see me. I can't see you. I can see the podium. So hopefully, hey, everybody. So please, who I am. Matteo Collina. I am part of the Node.js Technical Steering Committee at Node.js Technical Steering Committee. And, oh yeah, this is the crowd. Okay, sorry, guys. So I can see you. Just a second. I completely lost this. Okay, so now I see you. Okay, perfect. Okay, amazing. Hi, folks. Hey. Hi. Perfect. Yeah, okay. Now I can see you. Great. So I'm so sorry I could not be there in person. I'm still trying to figure out how to travel with my family situation. So I'm sorry. I would really love to be here. Hopefully, finger crossed, next time the world will be in a slightly better shape. So first of all, let's start talking a little bit about Pinot. So Pinot, what is Pinot? How many of you know Pinot? Hopefully a lot of you. Pinot is a logging library that I wrote in 2016. After I created Pinot, I also created a thing called Fastify, which is a web framework. So you can chat about both. I'm also keeping a newsletter at nodeland.dev about all my endeavors in open source and this library. So if you have been following Nodeland, you will have seen me talking a lot about Pinot in the previous months. Yeah, I have massive amount of downloads of NPM, so probably not a good thing to brag about that. But one of the key part and challenges of what I do is to, during my job, help companies building Node.js application, and as an open source maintainer, maintain Node.js and its ecosystem, build new libraries, see areas that are lacking things, and places where I can jump into, and that need my help. So Pinot is the fastest JSON logging library for Node. It has minimal features, but great community. Minimal, maybe not anymore, but we'll talk about them in a moment. It's downloaded a lot, 8 million times per month, and we have in version 7. Hooray, we shipped it. How does it work? You create, at basic, you instantiate your logger, and you call logger.info or error or word or whatever, and it just will print out in standard output a log line like the one over under there. Each log line is called new line delimited JSON. So it's a JSON followed by a new line. Very simple. Back in 2016, we introduced Pinot to the world, me and David Mark Clemens. And watch this talk, is the cost of logging. It's in that talk, we were saying that Pinot is actually really fast. Compared to alternative, is probably the thing that you should be using today. So, why it is so fast? And why it matters for this talk about multi-threading, okay? So why should we talk about this and care about this? Okay, so it is the bit. This is the Node.js event loop. You probably have not seen this diagram before too many times. It's a different representation of what happens when we receive an event loop, on how the event loop works. So in the basic case, the event loop is idle. There is nothing happening. It's waiting for an event to happen. When the event happens, the event loop, libuv, calls into C++ and execute a callback, a C callback, and C++ callback. After that happens, that typically invokes a JavaScript function. This is where our code lives. But before that, there's probably some little bit of Node core that is being invoked. Anyway, this is where our main code lives. This function typically schedules either some process.nextTick or some promises. Are you all using promises today, maybe? Is there anybody that still hold out, didn't concede to the dark side of promises? There's still somebody? I don't know. I know there's at least one person in the room that still hasn't conceded to promises. I'm joking. Anyway, so micro task. So after all of that is done, and all those next tick and promises have been scheduled, the ball goes back to C++, where we start processing the task queue. So it goes back into JavaScript work to execute those queues. And then we finish, and then it exits, okay? This is a great way of representing what happens at any given step of the event. And this happens so many times per second, right? So we don't worry about this. This is faster than a blink of an eye. So this is important to know because it's, let's say that you have a slow I/O operation, okay? Now, if you have an application that's taking a lot of time to stay there for a long time, you essentially have, your event loop is idle, right? So it can take more new or other HTTP requests or other stuff happening inside. This means that your application is idle, your event loop is idle, so naturally your application will increase the number of concurrent tasks it's taking. However, the more the number of concurrent tasks grows, the more grows the memory consumption. Again, this seems obvious. We are allocating more closures, more functions, more objects, more data. Pretty obvious, but it's important to note that. Well, if memory consumption grows, the garbage collector needs to do more work to clean things up, right? We create more, once we are done, we create more garbage. It needs to be collected. Somebody's going to do that. So it needs. The garbage collector, though, runs on our CPU. Now, how many of you are deploying Node.js, each Node.js application with 2 available cores? I'm not seeing anybody raise your hand. Oh, somebody. Yeah, I know there was somebody that knew how to do that trick. Okay? Like if you schedule with 2 cores, then you can have your Node.js process will actually run better because you can have a second CPU to run these things on. Anyhow, most of you deploy Node.js with 1 virtual core per application, which means that under high load, the garbage collector will steal CPU cycles from our JavaScript critical path. So essentially what will happen is that the more objects we allocate, the more JavaScript, the less of the JavaScript we can execute. So, ouch. So why all of this has to do with threads and multi-threading? Okay, well, we'll see. Anyway, what you need to remember in any Node.js application is that latency and throughput are connected. It means that if we want to increase the throughput of an application, very usually if we reduce the latency, the throughput will go up. Very fun stuff. Going back to this diagram to say where Pinot does its job. Okay, Pinot is optimized to reduce the amount of time it adds to in your JavaScript function execution. So the core idea of Pinot is that all its computation will finish within while the event loop is blocked. This is critical. So because Pinot does all the processing synchronously in one tick of the event loop, it does not leave much data to be allocated later in memory. Because of that, it's actually easy for the system the garbage collector to keep up. However, that has consequences. And the way we finished the talk in 2016 was saying that Pinot is more than a module, it's a way of life. And the reason of that, it's because we recommended to run all the post-processing steps as a separate process, including, for example, log formatting, sending it to remote destination, for example, Elasticsearch, or whatever you can mention, And we were more, for example, there were log rotation questions or support multiple destinations. So somebody wants, oh, I want to send all the logs to a file and then others somewhere else. And however, this was totally fine for a node from point of view, but it was really not liked by the operations team. The operations team wants each container to just as one process and one only. And so that was hard. And all users kept asking for those features. A lot of issues in our repos, okay? And we turned them down. But maybe we could do better. So we have tried to do better and solve a little bit of this problem. So let's go into a multi-threaded world. Multi-threaded means that we have worker threads, which is stable in Node 12, Node 14, Node 6, from Node 12 on. So it's stable on all LTS line. By the way, how many of you are still using Node 10? Nobody's raising your hand. So I'm very, I'm watching you. I know you are still using Node 10 somewhere in the audience. So, I'm spying from the corner of my eyes. I know you. Anyway, it's a worker thread has easy synchronization primitives, so which are called atomics. Now, it is the easy. So easy means simple, okay? But whenever you start combining the bunch, they are definitely not easy to combine them, okay? Anyway, atomics are great. Atomics are the secret sauce of worker threads, and we'll see an example of what you can do with them later on. So it is the question, can we use worker threads to build transport for Pinot? Well, yes, we can. In fact, using a separate thread for logging was initially prototyped by Mark Maron from Microsoft, that did a fantastic job in a library called LogPP. However, that library used a native add-on, and it was a little bit awkward to use, so not really a good dev experience. So, however, we started working into this, okay? And we were thinking and trying, and we couldn't work around the fact that the API of worker thread is not fast. Like, post message, like if you send a post message and you want to get a message back, well, how much time it will take? Well, it takes a little bit around 8 milliseconds per round trip, and which means around 125 messages per second, which is too slow. Like we want to be able to log 10,000 lines per second or something like that. Okay, so how can we reach those levels? Not good. So we investigated this a bit, and we have created a library called ThreadStream to solve this problem. ThreadStream uses a ring buffer. So main thread can write to copy data into this buffer without blocking most of the time. And the worker thread can actually read from the buffer without blocking most of the time. So the result is that you can actually just use this to write, to do things that can be slower to it will just work, okay? And it will just give you a lot more speed. Oh, sorry, no? Why? It's not flipping, okay? Okay, so it is a quick diagram of the problem. So you have a ring buffer. The ring buffer is implemented using a shared array buffer. What is a shared array buffer? It's a memory area that can be shared by two processes, by two worker threads. What it happens is that the transport owns a variable called read, and the main thread owns a variable called write. Those variables are held into another shared array buffer and another shared array buffer. Now, what we are doing here is the read. Sorry, I don't know what's happening. The read is a read buffer tells up until when the transports are read, and the write buffer tells how much the main thread has written. So by keeping those two in sync and moving them forward, the main thread can write stuff to the buffer as much as it wants without blocking. How? Just copying data inside that block. All of these is to support the new Pinot transport feature. So we use this trade stream library to create a single worker and that you can execute a lot of things on. So in fact, you can use the new system to, for example, send everything to a file, send data to Elasticsearch, or just print them out on your console. All of these will use a worker thread, okay? So it will be really fast. And it will not block your main event, which is great, minus a few cases. So how do we write a transport? Well, first of all, you can just use this Pinot abstract stream utility, and you can just take that and just use this build, pass an async function in, and use for await, and it will just basically work. Each object of source is the log line that was already parsed, so it's very easy to write one. Note that if you use this, you might want to use a library called HWP to improve the performance, but it's not strictly needed. What is a pipeline? A pipeline is a concatenation of multiple transports. So you can, if you want to do some transformations, you can, and you can also use actually use a transform stream to do those kind of things. Remember that if you do so, you will need to turn on enable pipelining. Last but not least, the exit problem. This was the hardest one to solve for this new architecture. I don't know how many of you know, how many have been in this problem, but whenever you receive, you call process.exit, the event loop is dead. Okay, you can't receive or send, do any HTTP call. Process on exit. Okay, you are essentially only synchronous code can be handled. You are in trouble. We are in trouble. How can we execute code inside process.exit? Well, we just don't want to execute generic kind of code. What we want to make sure is that all logs are flushed, and we can't do any I/O in there. So with the transport system, we can solve this problem. And this is actually very interesting. So process.exit, inside the exit event emitter, we can call a method called flash sync on the transport. Now, the transports, this flash sync is communicated to the transport using the shared array buffer, not post messages. Because it's communicated using this shared memory, in fact, it's a synchronous operation. But the transport still has an event loop running. It can still run its own events. So it can do all the asynchronous processing we want. And after it's done, we can just unblock the main thread. So we literally manually block the main thread, manually. Here is how it works. So when we want to end our stream, this is a simplification, some code was left out. What we do, we start reading from the state shared array buffer and using atomics.load, and then we communicate that the stream has ended, and then we start spinning. You see there is a while true, essentially. It's a while loop that runs forever, okay? We actually want to block the event looping. What we do is that we wait for 1 second of the red index to flip, to change. If that does not happen, it will return, and if red is not -1, it has not finished reading, it will spin again. This is great because we can actually synchronously block and wait for something to happen on the other side, on the transport. This pairs well with this library called onExit leak free. Now, The use of that library is a little bit tricky, but what you need to know is these functions will be called for you automatically. So what we do is that we make sure that whenever you allocate a transport or a worker thread from this system, it is automatically closed when it goes out of scope. So it's great, and we can do this and also make sure that whenever the process finishes, it actually call all of these mechanisms automatically. It's great. If you want to know how to test that, please reach out. I could be able to give you a little bit of hints. So last but not least, benchmarks. You have seen from Adrian the focus on benchmarks. So I would be very much surprised if there wasn't any benchmarks available in this code. So what happens is that we measure the performance of Pinot when logging in a Fastify application. Note that Pinot v7, it's not done, is not finished yet, okay? And it's, yeah, thank you. And so we did it by, we measured it, and it's, first of all, writing synchronously to a file. This is a default, or asynchronously to a file, or using a transport to a file. And this is great, and there is no surprises here. Well, there was a little bit of a surprise that the transport is actually slightly faster than the sync system. However, there is, the problematic one is the synchronous writing to Elastic. Like by default, if you create a Pinot library by default without turning it to asynchronous logging, and you pipe that system to Elasticsearch, to a transport that sends it to Elasticsearch, you will end having a problem because the actual throughput of your application will drop. So you could do asynchronous logging with Elastic, and it will be great. However, if we want to use, but this still requires having two processes. At the end, you can actually use a transport, the transport inside Pinot. And if you use the transport inside Pinot, you could send things to Elastic or wherever you want, and not having any performance drop. So you can read the full explanation in me announcing this blog post. So this is the time in which I do a demo, okay? So this is my demo. So I import Pinot, I create a transport stream, and I am writing all warn to this file called log. So, and then I'm sending stuff to Elasticsearch, and then I'm printing out to Pinot pretty. And there is a bunch of logs here, okay? So, okay. So what we do, we can just run transport. As you can see, this is pretty fast, immediate, and it's printing stuff out on the console, okay? But if I do tail out, you will see that we get all the warn logging errors in my code at the end. Finally, you know, the big question is, did we upload it to Elastic? And as you can see, we have now we have 14 log lines into Elastic, and here they all are. And it's pretty great because the system all works. So I keep demoing it, and it's still working over time. So that's it. Thank you very much. Thank you very much for your time. Please take some moment to go on Twitter and follow me at Matteo Collina. You can also ask me any questions over there if you want to. I'm pretty available, even to drop on a quick Zoom link if you have any questions. Yay, that's it, man. So one thing to note: NearForm.com. Hey, thank you guys. NearForm is hiring, so if in case you're interested in a role, please let me know. And you will see that there are plenty of roles in Europe time zone. So if you want that would definitely work for you. Hey! Thank you, folks.